So in today's video, we're going to be looking at elements and chemical bonding. This is a short little video to introduce you to the idea of what is going on when elements combine in chemical bonds. So first of all, let's talk about the group 18 elements, in other words, called the noble gases. So I want you to locate those on your periodic table. And what you should know is that because they are in group 18, they all have their outer shell full, right? And so because each of these noble gases have their outer shell full, they're extremely stable. They're not super interested in gaining or losing electrons. And when that happens, because that's the case, they have a full valence shell, and they're just not going to want to do anything. Okay, so they're going to be chemically unreactive. In fact, in grade 12, we talk about xenon compounds, and yes, you can form compounds of xenon, but you actually have to force its electrons to be removed for that to happen, which it doesn't really want to do, and it doesn't happen naturally in the world. Okay, so all other elements aside from the noble gases are going to react chemically, and they're going to react chemically because they want to get that full valence shell. Okay, they want to become stable. Okay, so it can do it, as we've seen before, in a few different ways. This should also feel like review from grade 9 as well, but we're going to kind of just remind you of that before we move on. So elements can give up electrons, forming a cation. Okay, like sodium, right? We know sodium has one valence electron, and any element in group 1 is going to want to lose that electron, and in so doing, it's going to become a cation. Okay, so sodium gets rid of its electron, and it becomes an ion. Okay, it can also gain electrons and form an anion, like chlorine. So chlorine's over here in this group over here, and it has 7 valence electrons. Remember, we can count over 1, 2, 3, 4, 5, 6, 7. Everything in this group has 7 valence electrons, right? And so, is it happy? No, it's not happy. It wants to have a full outer shell. So to do that, it's going to gain an electron, and that will make it negatively charged. It'll make it an anion. Okay, so the last little bit is one that we haven't talked about yet, but that should be familiar from grade 9, which is that elements can share electrons. And that is what happens in the case of fluorine gas, okay, which is F2. That's how we would write that chemical formula. So let's think about fluorine for a second and how many valence electrons it has. Well, again, counting over, we just saw chlorine, and we counted over and saw that it would have 7 valence electrons, right? But if we have fluorine combining with another fluorine, do either of these guys want to lose electrons? No, they're close to a full valence shell. So this fluorine's not going to want to donate an electron to that guy, or vice versa. So the only way that they can form F2 together is if they cooperate, is if they share. Okay, so here's what we see. So when they share electrons, it's like, this fluorine is kind of borrowing the electron from this guy, and vice versa. So then everybody has 8 valence electrons, and so that creates that stability. Okay, and when we create that, we create what's called a covalent bond. Okay, so there's your brief reminder of ideas related to chemical bonding. Hopefully you found that to be straightforward. And if you have any points of confusion, make sure that you reach out, and I'll be happy to clarify.